Hello everyone. Welcome you all again for the next class of computer science. So here in the first class from your syllabus we have started the first unit, that is computer system and organization. From this we have discussed the basic computer organization, types of software, memory units. We have discussed in the first video. Now in this video we are going to discuss Boolean logic, okay, and the number system and encoding schemes. So these three topics we are going to discuss in this video. So ready for this? And if you have any doubt, then you can give me, you can ask me in WhatsApp group. Okay. So now about the Boolean logic we are going to discuss. For this also I have prepared one PPT. So these two PPTs I will send you on mail today. So you can download at home. You can see. Okay. So later on if we will do any other programs, so I have prepared so many programs, practical programs, so many practical Python programs for you, so you can directly practice from that program also. So if you have any doubt, then you can ask me. So that practical programs also I will send you in a zip folder, so you can download at home and you can practice. Okay. So now here we have to discuss the Boolean logic. Now for this I have prepared this PPT for you, Boolean logic. Okay. Now see, Boolean logic is a platform of algebra which is centered around three simple words known as Boolean operators, or and not. That means these are the logical operations. These logical operations we have to do actually, and or not. These three operations are there. Okay. At the heart of the Boolean logic is the idea that the values are either true or false. That means after execution of the expression, you will get only one result, that is either 0 or 1. If it is 0, then it is said false. If it is 1, then it is said true. Okay, that is the Boolean logic. So that means some expressions you will get here. So there some operations you have to do, that is and or not. These three operations you will get only. After that operations you will get only one result, that is either true or false. Actually this Boolean logic is used to design circuits. Okay. So now see, here these are some gates, and Boolean logic gates and truth tables are given here, and see simple gates are there for and or not, and the functionality can be expressed by a truth table. A truth table list of output for each possible input combinations. So what about the truth table? Truth table, that means see some values you have to give, some inputs you have to give. Two inputs you are giving and one output result you will get. So how you are getting, so how you can show that is a truth table here. See, a truth table is a list of outputs for each possible inputs combinations. Okay. Precedence is there, not, greater than, and, greater than, or. So what about this? Everything you will understand step by step. Now see, this is written here A, B is there. This is A, B, after that F is there. These two input combination is there, and here you are getting result, that is F. So this is known as AND gate. AND gate you can draw like this. AND gate is this, and for this is the truth table. So how it is get? How it will get? See, two inputs are there. These are the binary numbers. Okay, 0 0 means 0, 0 1 means 1, 1 0 means 2, and 1 1 means 3. Okay, these are the binary numbers. So here 0 1 2 3, this is 0 1 2 3, these are the binary numbers here. So up to 3 bits, this is actually 2-bit input you can say, because this is A and B is there. A is one input, B is another input in the truth table. A is one input, B is another input. After that the result is there. That means 2 input is there. 2 input truth table is this. So here in this truth table, A's value if you are entering 0, B's value if you are entering 0, for that this is the AND gate, the result you will get 0 here. This 0 is there. So how you will get? See, when you are going to use AND operation, that means if single input is 0, then output always you will get 0. Okay, output always get you will false only. If one input is false, that means entire output will false. See, if you are entering suppose 0 0 0 1, that means 3 zeros are there inputted, and 1, if single input is true 1, that means output you will get 0 only. If you are entering 1 1 1 0, that means single input is 0, means enter output you will get 0, that means false. That is the logic of AND operation. Okay, after that OR is there. In OR actually what happens, see, when single input is 1, then the entire output you will get 1. If single input is true, that means entire output is true. Suppose you are entering 0 0 0 1, that means the result you will get 1. If you are entering 1 0 1 0 1 0 1, you will get 1 only, because your input is one single input is true. You have to see that only. If single input is true, that means entire output is true. In AND, in case of AND, if single input is false, the entire output will be false. Clear? And NOT means it is the reverse. If you are entering A is 0, that means it will give 1. Okay, that means the opposite it will show. If you are entering the input is true, then output it will show as false. So that means it will show the opposite result. Okay, so that is NOT. So these three types of gates you have to remember. This is AND gate, this is OR gate, and this is NOT gate. Okay, these are known as logic gates, and these are the truth tables. This is 1 bit inputs. In NOT, in case of NOT, you will get only 1 bit. See, only 1 bit you are entering 0, that means the result you will get 1. If you are entering 1, that means 0, the opposite you are getting. And in OR gate, see, same inputs are there, 0 1 2 3. So 0 0 means 0, 0 1 means 1, and 1 0 means 2, and 1 1 means 3. So how it will get, one list is there in this presentation. I will show you actually how to convert from binary to decimal, and decimal to binary is also there. So how these numbers are there in the truth table, I will show you. So just you have to remember this thing, that if two inputs are there, this is 2 input truth table, and result is there. If in case of OR, if single input is 1, that means output is 1. If single input is 1, that means output is 1. If two inputs are 1, that means also output is 1. And in case of AND, see, both inputs are false, that means false. Single input is false, false. Single input is false, false. And both inputs are true, that means the result is true. So that is the logic of AND or NOT. Okay, so after that, see, additional some useful gates are there, NAND, NOR, NOT. So if the operation you are doing AND, after that if you are implementing that operation, if you are going to show the opposite of this operation, then that is NOT. If you will use NOT in NAND, and then it is said as NAND. Okay, so after AND operation, what the result you will get, you have to opposite that. You are using NOT, that is why it will show the opposite result, that is NAND. So actually here in NAND gate, see, if you are entering 0, input is 0, both input are 0, that means output it should be 0 in case of AND. Okay, if you are if you are using NOT gate also in AND, then it is NAND. So here it has to come 0, but it is coming 1. Single input is 0, then it has to come 0, but you are using NAND gate, that is why it is 1. If you are entering here, say single input is 0, that means it has to come 0, but it is NAND gate, that is why it is 1. If you are both inputs are true, means it has to come true, but it is coming 0. Why? Because it is NAND gate. Clear? And in case of NOR is the same case. In case of NOR, see what gate is adding here. Okay, NOR, see, OR plus NOT, that is NOR. In case of OR operation, if single input is true, that means result has to come true, but it is coming false, because after OR, NOT is using here. Clear? So like that, these gates are there. This is exclusive OR. So the meaning of exclusive OR is actually here, actually how this operation is executing here. See, A bar B plus A B bar is equal to, you will get this result. So you have to remember that. What I said, that A bar B, what is the value of A bar? Means A not. That means A's value is 1. A bar means, that is, okay, I am going to show you this exclusive OR in Notepad. See, suppose A, just think this is a bar, okay, not A bar B plus A B bar is equal to, see what you will get, Suppose your input, both all inputs are true, 0. Suppose this is 0, this is 0. That means A and B's inputs are 0. We are entering here. A is 0 and B is 0. We are entering here. So I am going to show you here. See, A's value is 0. A bar means that is 1. Opposite. A bar B. B means B's value is 0 is already there. So actually A bar B means A bar B is there. That means here if it is not there anything between A and B, this is by default dot is there. AND operation is happening here. Okay. Then here AND operation is represented by this dot, and OR operation is represented by this plus symbol. You have to remember that. Okay. So now see 1 0, after that plus will come. Then A B bar, the value of A is what? This is 0 0, and B bar means 0, then opposite, that is 1. Clear? So after that if you will calculate this, then what you will get? 1.0, 1 and 0, that means single input is 0, the output you will get 0 here. Clear? Plus 0, single in 0 and 1, single input is 0, that means you will get here result 0, then output you will get 0. That is why here the value, see, this 0 is coming. Clear? Then how this 1 is coming? So I am going to show you here. A's input is 0 and B input is 1. Okay. So now see, A input is 0, that means you have to write the opposite, this is 1, and B input is 1 there, so here we have to write, okay, okay, B input is 1 there, so here we have to write not 0, this is 1. This is 1. Clear? So after that, for the next one, here see A B bar. So A value is 0, so this is A value is 0, and B bar, B value is what? B value is 1, so B bar means this is 0, this is 0. Clear? So 1 and 1, already you know the AND operation. If all inputs are true, no single input is 0 here, that means the output you will get here true, that means 1. After that 0 and 0, that means 0. 1 plus 0, in OR operation what is there? If single input is true, then output you will get true. That is why the result is 1 here. So this result is 1 here. Clear? So like this exclusive OR have to do. Clear? Okay. Go to the next one. This is truth table. Logical expression form. See, this is the truth table and this is the logic gate here. So from this expression, this logic gate is drawing here. So here just try to understand this truth table first. So actually this is 3-bit input, A, B, C. These 3 inputs are there. Okay. If 3 inputs are there you will get always 8-bit. Just remember that. Okay, 8-bit. You have to remember that. If 2 inputs are there only you will get 4-bit. How? See. Sorry. If 8 up to 8 numbers you will get, that means 7 up to 7 you will get. If 3 inputs are there are 3 bits actually, 1 2 3. If 2 inputs are there, that is said as 2-bit, and here the maximum number you will get 8 and it will go up to 7. Okay. If this is 3 input, then you have to remember the table always go to 7. If it is 2 input, then your table always go to 3. If it is your 4 input, then your table go up to 15. You have to remember that. Okay. So now this is 3 inputs are there. This is 3-bit. So now here first one is 0 always. 1 2 3 4 5 6 7, up to 7 it is going. That means 8 rows you will get here. Okay. So 0 to 7 you will get. It will always start from 0. And 0 1 2 3 4, what about that? These are the decimal numbers. So that decimal numbers it is converting up to binary. Then these binary values are written here in this truth table. Clear? So if you are writing 0, then all inputs should be 0. Then these zeros will come. Here actually how to calculate this? This is 2 to the power 0. Just try to understand this. The value of C is 2 to the power 0. This is 2 to the power 1. This is 2 to the power 2. Okay. If it is 2 to the power 0, then what is there? Okay, I'm going to show you notepad again. Okay, the last one, this is 2 to the power 0 means always what to come? 1. Then before it, 2 to the power 1 means 2. Then 2 to the power 2 means 4. Is it? So see here, see 4 to 1. The value of a is 4 here, this is 2 here, 1. So 2 to the power 1 means 1, 2 to the power 0 means 1, 2 to the power 1 means 2, 2 to the power 2 means 4. Clear? So now see how the values we are getting here, the value of 1, 2, 3, 4. Okay. Oh, wait. And enter. So here for suppose 0. So here the results how you will get? Here also you will get 0, 0, 0. Clear? Now go to the next one. This is suppose 1. This is suppose 1. Okay. So for 1, what to write here? In place of this 1, you have to write 1, and this is 0, and this is 0. Clear? So now again, wait. Okay. Now for 2 suppose. So what to write for 2? For 2, which bit required? Do you know which bit? For 2, this 2 is already there, this 2 is required here. So that means this is also 0, and here this one is required, that is 1 we are writing here, and this one is 0. Clear? After that 3 is needed, 3. Now for 3, how you will get 3? This 2 bit is required for 3. Clear? This 2 also required and this 1 also required. That is why this one is not required, that is 0. And which we need, there you have to write this is 1, and here you have to write 1. That means 1 plus 1, that is 2 plus 1, 3. Clear? After that 4 you have to write. Okay. So now for 4 is the decimal number here. For 4, only this 4 bit is required, only this bit is required. That is why here we have to write 1, and remaining 2 are 0. Clear? Now for 5 suppose, this is 5. How you will get 5? See, try to understand how you will get. 4 plus 1, 5, isn't it? 2 is not needed. So here in place of 4 we have to write 1, and this is 0, and this is 1, 5. Now suppose you have to get 6. Okay, so how you will get 6? 4 plus 2, 6. So here this is 4 is needed, and this 2 is needed, and this is 0. Clear? 6. After that 7. So for 7, 4 plus 2 plus 1, 6 plus 1, 7. So here 1, 1, 1. So like this table has written here. For 2 bits, suppose this is A and B, 0, 0, 0, 1, 1, 0, 1, 1. That we have done in the first example, truth table. Clear? And this is 3-bit truth table. That is why these 3 inputs are there, A, B and C. So these values are there. So like this truth table has designed. After that this F is there, outputs are there. So these outputs will come depending on AND or NOT operation. Okay, if it is AND, that means all inputs are 0, it will come 0. If it is AND, all inputs are 0, 0. If it is AND, like this. If it is OR, if single input is 1, then it has to come 1. So like that it will come. Okay, okay, done. Now this truth table complete. After the logical expression is coming here, F is equal to A, B. A and B is there, A and B, because if it is not there anything here, or if it is dot there, that is AND operation. Clear? Plus means OR operation. A and B, or B and C, or A and C. Clear? So here see, A and B AND operation is there. That is why this AND gate is drawing here. From A it is drawing, from B it is also coming. Clear? So like this you have to draw the logic gates. So from where you are dragging the lines, so there you have to draw a dot here, like this. Okay, that means you have to clear from where you are drawing the line. So now see, plus is there, that is different. B and C is also there, so B and C we are drawing this gate, see, AND operation. So B is coming from here and C is coming from here. After that A and C is there, so A, from A it is coming and from C it is coming. After that the three gates A and B, B and C, A and C, between this among these three gates plus operation is there, that means OR operation is there. That is why this OR gate we are drawing here and dragging the lines from all the AND gates. It is clear? So like that you have to draw the logic gates. I think it is clear. If you have doubt, then you can ask me in WhatsApp or you can call me. All three circuits implement F is equal to A and B. So now see, from A and B two inputs are there, so this is AND gate, and this is NAND. This is not A not, B not, this is NOR gate. Okay, this is not OR gate, this is NOR gate. After that A and B, so there OR gate is there, NOT gate is there, AND gate is there. Clear? So just try to understand from these circuits how it is doing. After that derivation, the logical expression from the circuit. That means this logical expression is there. From this logical expression you are getting this, that means you are getting the expression from this logic circuit. Suppose A and B input is there, so what the output exactly, the logical expression what you will get, so this expression you will get from here. So how? See, A, B, two inputs are given here. What is the gate here? This is OR gate, so you have to write plus between the operands. A and B two inputs are there, so we are between these two inputs we are writing plus, that means OR. Clear? And this is NOT gate, that means in this gate, see, in this OR gate, what is the input here? A is there and this is B, B not is there, B bar is there, that means B not, and this is OR gate, so that is why A plus B bar. Clear? And in the next OR gate, see, A bar and from B it is coming, B, A bar B, so that is why, and this operation, see, and between this and this gate, so that is why A and A plus B and A B bar, so these two gates done, these two OR gates combined by using AND gate done. After that this gate and this gate is combined by AND again, so that is why A B, this gate and this gate is already there. After that this gate you are adding A bar B, so that is why A bar B is adding here. So like that from this circuit you have to write the expression. Clear? So some Boolean identities are there. Identity x dot 1, if you will get, then the meaning of this is x also. And or here see, in AND version this is OR version. In AND, x dot 1 x, x dot x bar means 0. How it will x dot x bar means 0? How can you identify? How can you implement? See, x means true, true means there is 1, x bar means false, that is 0. 1 and 0, always it will come 0. Clear? After that x y, you can write y dot x also. X dot y plus z, you can write xy plus xz also. So here in distribution and commutative, so like that. So different names are given here. So from this name you can see the list. In OR what you will get, in x and what you will get. So here see, in case of OR, x plus x bar, the value of x is 1, that means true. X bar, this is false, that means if 1 or 0, single input is 1, that is why it is coming 1. So like this table you can see. So these are the left part. So here see, so you can see from here. So different identities are there. So these identities you have to remember, okay, for Boolean expression. So you have to understand the mean terms, concept of mean term and max term is there. So mean term means sum of product and max term means product of sum actually. So here is also this truth table is there, the same truth table. And in case of mean term, what you are writing, exactly what it is there in the truth table, you are writing that only. See, that means 0 means in position of x, this is 0, this means x bar. y0, this means y bar, z0 means z bar. So this is why writing here x bar, y bar, z bar in case of min terms. Okay, and the last one, see here, in place of x this is 1, this is true, x, no bar is there, so here is writing x, and y true, y, z true, z. Here see, this is false, 0, that is why here you have to write x bar, and this is true, that is why y, no bar, z, no bar. See, x bar, y, z. Clear? So, and these terms you can write like this also: m0, min term 0, min term 1, min term 2, min term 3, min term 4, 5, 6, 7. According to the decimal numbers, you just write m0, 1, 2, 3, 4, 5 like that. Okay. And in case of max term, it is complete opposite of this min term. Clear? If it is x bar, there no need to give bar. And see here, if it is 0, there you have to write x, as true you have to write there. And here is AND operation, and here is OR operation. Clear? AND operation, dot you have to write, or you may not write, and here you have to write plus for OR. Clear? So this is true, false, in x is false, but there you have to write true. See, true. And this is false, or this is true, there you have to write false, you have to write false. This is false, a bar, y bar, z bar. Clear? This is the opposite of min terms. Clear? Now sum of min terms. Sum of min terms of sum of products, you can say. So here see what we are doing. Wait, cursor is not coming. Okay, from the truth table can express this. Here see, x bar, y bar, z. This is what? X bar, y bar, z means what? M1, it is writing here. So here see, x bar, y bar, z. X bar, y bar, z means this is M1, M0, M1. So here it is M1 plus x, y bar, z means this is true, false, false. That means 0, 1, 1. This means 3. 0, 1, 1 means 3. So you have to go to the position 3. 0, 1, 2, 3. This one, 0, 1, 1. So here, meantime, what? This is 3, M3. Or M4, 0, 1, 2, 3. For the next one, M4 is coming here. How? M0, M1, M2, M3 has to come here. Is writing mistake. And XYZ is there. XYZ means M7. XYZ. All these are true. So this is M7. 0, 1, 2, 3, 4, 5, 6, 7. So this is printing mistake. So here M3 will come. So like this, you have to write the sum of min terms. So this is XYZ plus, that is why X bar, Y bar, Z plus X, Y bar, Z bar. That means these two inputs, you are doing the sum. That is why this plus is there. So sum of max term is also there. If sum of max terms, you will get, that means see, express the Boolean function A and B bar C. In sum of min terms, what to do? In sum of min terms, actually see, all inputs should be there. So here see, actually what of the sum of, cursor is not coming. Okay, this one. So x bar, y bar, z, that means 3 inputs are there. X, y, z, these 3 inputs are there also. X, y, z, these 3 inputs are there also. But in the next slide, see, A plus B bar C. But here in this A, B and C is not there. And B and C is there, A is not there. But in sum of min terms, all inputs should be there. Okay. For that case, what you can do? If B is not there, then you have to write A dot B plus B bar. Clear? Then after execution of this line, what you will get? AB and AB bar. AB and AB bar. Still missing, there is C. Okay. So AB is there already. Then C plus C bar. Then what you will get? ABC, ABC bar. ABC, ABC bar. It is clear? So after that, what is not there in B and C? A is not there. So for that case, you have to, same thing you have to do here also. AB, C plus C bar. AB, C plus C bar. Okay, okay. In this AB, C plus C bar, you are adding, and this AB bar, again C plus C bar you are adding. So after ABC you will get ABC bar, you will get. Here also AB bar C, A B bar C bar you will get. So after that, see A B C is there, and if the same output you will get, then you have to take one only. If ABC is there, and here also if it is ABC, no, okay, ABC bar, ABC bar is there, here you will get ABC bar, ABC bar you will not get, and okay, that means 4 inputs are there already. ABC is there, ABC bar, A B bar C, A B bar C bar, okay. After that, for B and B bar C, A is not there. The same procedure it is using here, B bar C A plus A bar. So B bar C A. So you can write A B bar C, and here also A bar B bar C. Done. So combining all terms you can write like this. If the same term you will get again, then you can remove one. So for all these terms it is writing M1, M4, M5, M6 and M7. So how to get M1, M4? So you already know. So one more thing you have to write, SOP in sum of product, you can use this sign. In POS, pi symbol is used, and here this sigma symbol is used. Clear? So this symbol also you have to remember. In SOP, this one you have to use, and in POS another one is there. So yeah, I'll show you. So this line also you can write like this also. F, that means function, ABC, only ABC inputs are there, that is why ABC, these 3 inputs are there. And what are the min terms values? 1, 4, 5, 6, 7. So 1, 4, 5, 6, 7 you are writing like this. So this expression, this same expression you can write like this also, and the same expression you can write like this also. This is the SOP form. Done. Now go to the next one. So this is product of sum or max term. So the same thing you are doing here. X, Y, Z is not there. X, Z, Y is not there. So here X, Y plus X, Y plus X bar, X, Y plus Z bar. So what it is doing? This is the law, distributive law, or you can write like this also. X bar plus Y is equal to X bar plus Y plus Z bar. So you can use this also. So here which is not there, you can add here like this, Z plus Z bar, Z dot Z bar. But in the previous one you have added Z plus Z bar. See, in the previous one C plus C bar you are writing here, and here in this slide you are writing Z Z bar. So like this you can add. So if Z is not there, X, Y, Z is not there, then you can write like this. So here see, your expression is X, Y plus X bar Z, the product of sum. So here actually this is not product of sum. This is sum of min terms it is writing here. So sum of max term you have to convert. After conversion you can write like this. So here after conversion you are getting this result. So from this result which is not there, you are adding that. If sum of product is there, then AND operation is there between the product plus X bar Z. This is also sum of min term. So you have to convert it to max term. Max term already you know, in between the inputs your plus is there. So after conversion this you are getting this result, X bar Y, X plus Z, Y plus Z. So from this expression, try to understand this expression. So X plus Y, Z is not there, so you are adding Z like this. X plus Y, Z, X plus Y, Z. Then X bar plus Y, Z bar, X bar plus Y, Z bar. It is clear? So here is also X plus Z, which is not there, Y is not there, plus Y dot Y bar. So X plus Y plus X plus Z plus Y you will get, X plus Y plus Z, and then X plus Z plus Y bar. So X plus Z bar, Z plus Y bar. After that Y plus Z is there, Y plus Z plus X dot X bar. So X you have to add, that means Y plus Z plus X, X plus Y plus Z, and here also X bar plus Y plus Z, X bar plus Y plus Z. So this is sum of max term. So here it has to represent by using this symbol. Clear? Remaining are same. So you have to write like this. Done. Sum of min terms and sum of max term also we have done. Try to understand. This is easy. And these are graphic symbols of truth tables. Already we have done. That means and or not operators already we have done. And or not. De Morgan's law is also there in your syllabus. De Morgan's theorem, basically two sets of rules, laws developed from the Boolean expression for and or not. These two De Morgan's laws are this. See, first one is this: a dot b whole bar is equal to a bar plus b bar. So De Morgan's, this is one De Morgan law. So here you can write like this also. See, a plus b, a dot b whole bar, if it is there, then you have to remove this bar. If you are removing this bar, then you are getting like this: a bar, this plus, and this is this dot, it will come plus here, and b bar. Okay, this De Morgan law you are proving using truth table. This is, see, two inputs are there, a and b. These two inputs are there, 0 0 0 1 1 0 1 1. So there are 4 bits you are getting, 2 bits, 4 rows you are getting, 0 1 2 3. Okay, so now a dot b, this a dot b is there. So for a dot b, a and b, 0 and 0 0, 0 and 1 0, 1 and 0 0, 1 and 1 1. Now you are using this not here. That means a and b not. That means 0 1 1 0 1 0 1 1 0. Okay, after that you are getting this, so you have to prove that. So that is why a bar is there, so you are writing a bar. That means a is 0 here, here you are writing 1, 1 here you are writing 0, 0 you are writing 1, and 0 or 1 you are writing 0. Similar to b also. And here see, your OR operation is there, a bar plus b bar. So OR operation means, already you know, if single input is 1, that means output you will get 1. That means all inputs are 1 means 1. Single input is 1, 1. Single input is 1, 1. All inputs are false means 0. Okay, this is the first theorem. After that, De Morgan's first law, it is showing using the truth table logic circuit. So this is the logic circuit. And here the second theorem is this: a plus b whole bar, this is plus here, and a bar dot b. Similarly, how we have done in the first one, so you can see here also the opposite one. So a plus b is here, there was a and b, and here a bar dot b bar. What you will get here, see, this is a dot b bar, a dot b whole bar, and here a plus b whole bar. Okay, so same thing we are proving like this. Done. Okay, now number system is coming. So number system, you will get decimal number system, binary number system, octal number system, and hexadecimal number system. These number systems are there. So you have to remember that decimal number system always 10-bit number system, 10 base number system. The numbers you will get there 0 to 9, 10 numbers you will get 0 to 9. And in case of binary, you will get 2 based. This is 2 base number system. There you will get only 2 numbers, that is 0, either 0 or 1. And in octal number, that is 8 bit number system, there you will get 8 base number system, there you will get 8 numbers from 0 to 7. Hexadecimal 16 based, there you will get 0 to 15. Okay, now decimal number system, the number system that we use our day-to-day life, the decimal number system. So 0 to 9 you will get here. So it is written, I have already told you. And this is for example of decimal number is 1 2 3 4 is the decimal number. Okay, decimal number 10 base, binary number 2 base, octal number 8 base, hexadecimal number 16 base. So see, decimal numbers 10 base means you are getting the numbers from 0 to 9, and binary number 0 and 1, octal number 0 to 7, hexadecimal number 0 to 15. So 0 to 9, 10 numbers are there. For 10 you are writing A, 11 B, 12 C, like that up to F. This is 15. Okay, this is hexadecimal number. Binary number system, this is used 2 digit numbers, 2 base, the same thing it is discussing here. Calculating decimal equivalence. Binary numbers, if you are writing 10101, 2 is there, that means this is base. This is base, this is the binary number. Okay, so step 1, see how you will get this binary to decimal. 1 into 2 to the power 0 into 2 to the power 1 into 2 to the power 0 into 2 to the power 1 into 2 to the power. From the last 1 into 2 to the power 0, this is 2 to the power 0, again 0 into 2 to the power 1, 1 into 2 to the power 2, 0 into 2 to the power 3, 1 into 2 to the power 4. So see, this is the last one, 1 into 2 to the power 0, 0 into 2 to the power 1. So like that it will get. So the calculation if you will do, then the decimal number you will get. Step 2. So after calculation these values are coming. 2 to the power 0 means 1 into 1, this 1 is coming. 2 to the power 1 means 2 into 0, so 0 is coming. And then 2 to the power 2 means 4 into 1, 4 is coming. So like that these numbers are coming. So if you will add this decimal number you will get 21. Clear? So like that you can convert from decimal to binary to decimal number. Octal number system, that is 8 base number. So there the numbers you will get 0 to 7. So you can read this slide, so you will understand everything. Calculating decimal equivalent. So from this octal number it is converting to decimal. That means if you are converting from any number to decimal, so you have to multiply with the base to the power 0, 1, 2, 3, 4 like that. Okay. The binary number base is 2. That is why we have written in the previous example, that is 1 into 2 to the power. And here the base is 8. That is why 1 into 8 to the power we are writing. Okay. So you will calculate and you will get these values. Hexadecimal number. So for A, C, 10 is there. For B, 11 is there. For C, 12 is there. So like that up to F, 15 is there. So these are the hexadecimal numbers, 0 to 15, 0 to 9, then A to F. Okay. So you can read from this slide. Calculating decimal equivalence. So from hexadecimal to decimal, how to convert? See. So like this, you have to multiply with the base to the power 0, 1, 2, 3, 4. The same procedure. Conversion of number system. Decimal to binary. So here how to convert decimal to binary. Binary to decimal already you have done. You have to multiply with the base. And here see, decimal to binary, what you are doing. The decimal number is 29 here. You are dividing by 2. That means result is 14 and remainder you will get 1. Okay. Then result is 14. Then again 14 you are dividing by 2. The base of the binary number is 2. That is why you are dividing the number by 2. It is clear? So you are getting like this. 7 remainder is there. 0. And again 7 you are dividing by 2. That means result is 3. Again 1 is remainder. 3 dividing by 2, result is 1, and remainder again 1. And again 1 dividing by 2, that is 0. This is 1. So from here the numbers 1 0 0 0 1. So 1 1 1 1 0 1. So from the last you have to take the numbers. The result is that 1 1 1 0 1. So the binary number of 29 is from the last bit 0 1 1 1 0 1. See. So from here you have to see 1 1 1 0 1. So like this you can convert from decimal to binary. Octal to decimal. So octal to decimal conversion is this. See, try to understand. Octal to decimal, you are multiplying the base. If you are converting to decimal from any number, I have already told you, you have to write the base only. That means 4 into base, multiply with the base to the power 0 1 2 3 4 like that. Okay. So after that, binary addition. So how to add binary numbers? Okay. 0 plus 0 0, 0 plus 1 1, 1 plus 0 1, 1 plus 1 1 0. How? That means 1 plus 1 means what? 2. 2 means the binary number of 2 is what? 1 0. Already we have discussed in the truth table. Binary number of 2, 0 1 2 3. That means for 0 what? 0. For 1 0 0 1. For 2 0 1 0. For 3 0 1 1. So like that. So how addition has done, it is showing here. See, 0 0, okay, 0 0 1 0 1 1 0 1 1 1 2 it has to come. For 2 the binary number is this. That means to get 2, what you will get? 1 0 1 1. The sum is coming here and carry is coming here directly. So some another examples are there, so you will understand better. So here 0 0 0 3 inputs, this 1, okay, this is 2 for 1 0, and 1 1 1 means this is 3 actually. 1 plus 1 plus 1, 2 3. For to represent 3, the binary number of 3 is 1 1 3. If you have to write 3 1 1, that means how you will get. For 3, this is sum and this is carry. Okay, and this is ones complement. Ones complement means the opposite of the input number. 1 0 0 0 1 1. That means for 1 you are writing 0 1 0. In place of 0 you are writing 1. In place of 0 you are writing 1 1 0. This is ones complement. This is ones complement. This is clear. So after that, after two's complement is there. So after one's complement you have to add 1. That is one. That is two's complement. Clear. So now see, this is one's complement. You are converting to you are doing one's complement first. After that, what the result you will get, you are adding 1 with that. See, this 0 1 0 1, that means one's complement. 1 0 1 0, that is what the values are there, you are writing the opposite value here. After that, after one's complement, you are adding 1 here. So see how binary addition it has done, you will understand clearly here. 1 plus 1 means 2, you know. For 2, binary number is 1 0, so 0 is coming here and carry is 1. Okay, that 1 plus 1 again 2, this 0 is coming, then again 1 is there, then 1 plus 0, this 1 is coming here. After that these numbers are coming. Okay, so this is 2's complement. So after that encoding scheme is coming here. Encoding means already you know, that is the another topic you are going to discuss now. To change something into a system for sending message secretly, or to represent complicated information in a simple or short way. This is encoding. So basic of encoding schemes are there in your syllabus. So about ASCII we have to discuss now. ASCII is the American Standard Code for Information Interchange. In the older days of computing, ASCII code was used to represent characters. The English language has only 26 alphabets and a few other special characters and symbols. The table below provides the ASCII characters. So now see, if you are typing A, computer understand it is 65, not 65. It will convert to binary 1001, like that, any value it will get, that is digits. So digital language computer understands only. Okay, after that, see, these are the ASCII chart I have downloaded from net. I am going to show you so you can see at home. Here see, this 65 means this 65. This 65 means A, and B means 66 means B. So like that these numbers are coming. For other symbols also, which number is there, so you can see from here. These are the ASCII values. After that, Unicode and code points. Unicode character set map each character in the world to a unique number. Okay, this ensures that there are no collisions between alphabets of different languages. Okay, that is actually Unicode. These numbers are platform independent. These unique numbers are called as code point in the Unicode terminology. Okay, so now see here, U plus 1E4D. U plus denotes Unicode, and 1E4D is the hexadecimal number. Already you know the hexadecimal numbers, you will get 0 to 15. So A, B, C, D, E, F. So this is the hexadecimal number. So value assigned to the character. The English alphabet A is represented like this, U plus 0041. So other values you will get from here. So you can go to the link. Utf-8 encoding. So now that we know what is Unicode and how each alphabet in the world is assigned to the unique code points, we need a way to represent this code point in the computer's memory. This is where character encoding come into the picture. One such encoding scheme is Utf-8. This is one other encoding scheme. And Utf-8 encoding is a variable size encoding scheme to represent unique Unicode code points in memory. Variable size encoding means the code points are represented using 1, 2, 3 or 4 bytes depending on their size. Okay, 1, 2, 3 and 4 bytes characters you will get there. So here see UTF-8 1 byte encoding it is showing here. If it is 1 byte encoding, you have to place 1 byte means what? Already we have discussed in case of bit and byte. So bit means 0 or 1. Okay, 1 byte means if it is 8 bit is there, that is said as byte. If 8 bit, then it is said as byte. Okay, so 8 bit is equal to 1 byte. So here if 1 byte correct encoding is there, that means 8 bit is there. So before the bit we have to write here 0, that is 1 bit, 1 byte encoding. Okay, so here see English alphabet A Unicode point is this, its binary is this. So this is 8 bit, 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 characters are there, 8 encoding schemes. So here if it is 1 byte, if it is 1 byte, then we have to place 0 like this. Okay, so after that see 2 byte encoding, 2 byte encoding, 8 bit 8 bit, 2 byte. Okay, 8 bit is equal 8 bit 8 bit 8 bit 1 byte, 8 bit 1 byte. So here if it is 2 byte encoding, then we have to write in first 8 bit first byte 110, in second byte 10. Okay, this is 2 byte encoding. And in 3 byte encoding, in the first byte you have to write 1110, and the second byte 10, in the third byte also 10. This clear? So now it is 4 byte encoding. That means in the first byte we have to write 410, second byte, third byte, and fourth byte 101010 you have to write. Okay, so this is 4 byte UTF encoding. So after that Utf-32 encoding is there. Utf-32 encoding is fixed byte encoding schemes, and it uses 4 byte to represent all code points. That means 32 bit means 4 byte, 8 bit 8 bit 8 bit 4 byte. So you have to write like this. Okay, this is the binary number of A 100001. So this binary number is coming here, and these 4 bytes are coming 000. 3 bytes are coming 000. This is 4 byte. Okay, so ISCII is also their Indian script code for information interchange. So these ISCII includes this Assamese, Bengali, Bangla, Devanagari, and these languages are there. Okay, ISCII. So this cert is also there for ISCII code. So you can see from here, and this code is also given here for Devanagari 57002, for Bengali 57003, for Tamil 57004. So you can see from the list. Thank you. So that means we have discussed these 3 topics here from your syllabus. So for the next video you have to prepare yourself. So you can see from here. If you have any doubt, then you can ask me in WhatsApp. Okay, for next class you have to wait. Okay, some more topics we have left to complete this unit 1, so we will discuss that topic also in the next video. Okay, so here we have not discussed concept of compiler and interpreter, operating system, and concept of cloud computing. These 3 topics we will discuss in the next video to complete the unit 1. Okay, thank you, bye bye.